What's up, sixth graders? Chapter 7, Section 7, Solving Inequalities using multiplication or division. I'm going to speak in this voice the whole... No, I'm not going to speak in that voice the whole time. It's going to drive me nuts. All right, you guys. How do I use the multiplication? I'm going to put and division properties of equality. Properties of equality? This is how I entertain myself. Properties of equality. Do vertical lines, man. It's the nemesis of this thing. To solve inequalities. How do you do it, man? I don't know. You're going to have to teach me. No, I was joking. I'll teach you. If you guys pay me $1 million, I'll teach you. Okay, deal. That's a question mark. It's a special kind of question mark. It's a little bit benty and stuff. Okay, but in all seriousness, how do we use the multiplication and division properties of inequalities to solve inequalities? Well, multiplication property of inequality. Let's think about it in words. When you multiply each side of an inequality by the same positive number, the inequality remains true. Okay, 8 greater than 6. Is 8 greater than 6? Yes. What happens if I decide to multiply each side of the inequality by the same positive number? Like, how about I multiply both sides by 2? Do you think that this inequality will stay greater than? Well, 8 times 2 is 16. 6 times 2 is 12. Is 16 greater than 12? Oh, yeah. So yes, I'm able to multiply both sides by 2 because then the quantity on this side will still be greater than the quantity on this side. Using the algebra, and I'm not sure this is all algebra, but okay. X divided by 4. I don't know if you guys remember this, but the inverse operation of division is multiplication. So we're going to multiply both sides by 4. And that's using the multiplication property of inequality. And when we do that, if you remember way back when we talked about this, is like multiplying by a fraction, 4/1. Remember that? The vertical line situation? That's so cool. Okay, the 4s are going to cross cancel, right? Because the greatest common factor of 4 and 4 is 4. So you divide both by 4, you get 1. X times 1 is X over 1 times 1 is 1. That's X over 1, or just X. I don't even need to put the over 1. Right side, 2 times 4 is 8, so X is less than 8. Okay? Well, the division property of inequality is the same thing, man. You have the division property of inequality. When you divide each side of an inequality by the same positive number, then the inequality remains. I'm not going to highlight remains this time. True. Is 8 greater than 6? Yes, because you'd rather have 8 pizzas than 6. Well, I don't know. That's a lot of pizza. You might vie for the 6, depending on how many people there are. Could I just decide to divide both sides by 2? Yes, using the division property of inequality, of course. 8 divided by 2 is 4. 6 divided by 2 is 3. 4 is greater than 3. And 8 was greater than 6. So the inequality stayed the same the whole time. Okay, using the algebra, 4 times x is less than 8. We're going to decide to divide both sides by 4. I like how they used the division sign with the 2 dots, which has now been made illegal. But over here, they decided to use the fraction bar, which is what you're going to do. There's a hidden multiplication between 4 and x. The inverse of multiplication is division. We use a fraction bar to show it. Oh, wait, where's my highlighter? Come on, let's do this. Use the fraction bar to show it. Divide both sides by 4. 4 divided by 4 is 1. Do I need to put the 1x here? No. And then 8 divided by 4 is 2. X is less than 2. Sweet, man. So wait, does this remind you of something you've seen before? I don't know. Maybe the multiplication and division properties of equality? It's the same thing, y'all. It's the same thing. Except for now it's got an inequality, which means the 2 sides aren't equal. All right, whatever. You already know it. Some of you are like, I already get it, man. I already get it. How do we solve an inequality? Inequality means not equal. It means that the two sides aren't equal. Using multiplication. Solve. That means find all of the values of the variable that make this true. And then we're going to graph those solutions. Let's do it, man. Okay, I'm going to rewrite this. Unlike you guys who are really lazy, I'm going to write right in the middle of this space right here. X divided by 5 is less than or equal to 2. Okay? I want to get x by itself, because when I get x by itself, then I'll know all of the values of x that make this inequality true, and I'll also be able to graph it, right? So how do I get x by itself? I have division here. So am I going to use the division property of inequality? No! What's the inverse of division? Multiplication. I'm going to do this in red so you guys can see it and it's really obvious. If I multiply this side by 5 over 1, do you guys see how the 5 are going to go cross cancel? I'm out of here. Okay. But if I multiply the left side by 5 over 1, guess what I got to do on this right side? Multiply by 5 over 1. But hold on, I'm going to write 5 over 1. How do I show multiplication here and make this a fraction? Easy. You make it a fraction, and then you can put it in parentheses. And I know that over here, the 5 over 1 comes before the parentheses. It means multiplication. The 5 over 1 comes after the parentheses. It means multiplication. It's all good. That works. So back to the left side. 5's cross cancel. They go away. They become 1. 1 times x is x. X divided by 1 times 1 is 1. That's just x, right? It's 1x over 1. You want to see what's really happening. It's 1x over 1. But of course, that can just be written as x. Because if you multiply x by 1, you get x. If you divide x by 1, you get x. Okay, right side, 2 times 5 is 10. Now I'm writing in red, okay. And 1 times 1 is 1. Do I need to put over 1? No, because any number divided by 1 is itself. So this represents all of the solutions in the solution set. I'm going to put a 10 right here, because when x was by itself, you got 10 over there. Then I'm going to number by 2's because I'm just one lazy guy. I don't got time to write the numbers right here. Okay, now let's highlight all the places where x can be. Can x be 8? If I substitute 8 in for x, is 8 less than or equal to 10? This is a less than sign because it looks like the letter L, L-E-S-S. Yes, 8 makes this true. I'm going to highlight it. Perfect. How about 9? Is 9 less than or equal to 10? Yes, I'm going to highlight it. Perfect. Is 10 less than or equal to 10? Well, it is equal to 10, so yes. Perfect. Well, I'm going to make this dot a little bigger. I know. Some of you already know where I'm going. That's good. That's good. You're smart little cookies, okay? You're smart little cookies. Oh, why did I make that so big right there? Oh, now I have to fill the whole thing in. Da, na, 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 na. Okay, wait, 12. Is 12 less than or equal to 10? No, of course not. Don't let your brother or sister try to convince you otherwise. How about I'll give you 12, but you get 10? That's fair. No, it's not fair. It's totally not fair. So x can be all of these numbers over here. Oh, look at that arrow. That's beautiful. Make your arrows nicer than mine, okay, guys? All right, thank you. Remember, what you do to one side of the inequality, you must do the same to the other side. We multiply this side by 5 over 1. Here's the inequality. On the other side, we do the same thing. We multiply by 5 over 1. Use the blank to undo the blank. Use multiplication to undo the, I can hear you say it, division. And look, I'm not even writing out the whole words because I'm too lazy. Isn't that horrible? You guys are the same. We're doing good. Let's move on to the next example, man. We're killing this. We're doing so good. What should I say? I'm doing so good. I don't even know how I do it. Jeez. I think it's because I eat my vegetables. Okay, hold on. Next one. Is that still a thing, eating vegetables, or are those bad for you now? No, vegetables are good for you. How do we solve an inequality using division? This is such a pattern. Last time we used multiplication. Wait, hold on. And now we're going to use division. Okay, yeah. Solve. What does solving mean? It means finding all the values of the that make the true. All the values of the variable that make the inequality true. And then we're going to graph the solution, just like we did on the last one. So I'm going to write it out here, guys. 4 times n is greater than 32, or 32. Okay, this is a coefficient. It's the number that's multiplying the variable. What operation is going on between 4 and n? Rhymes with multiplication. Nicely done. It's multiplication. What's the inverse of multiplication? I can hear you say it. I can hear you say it. It's division. And I'm going to use pink because I have not used pink yet. Look at that. It's beautiful. I'm going to divide both sides by 4. On the left side, what happens to 4 divided by 4? Well, that becomes 1, silly goose. So now I have 1n. Do I need to put the 1 in front of the n? No. I'm just going to put the n like that. I could put the 1 there. If you want to put the 1 there, go ahead and put the 1 there. Okay. 32, wait, whoa. If I divide both sides by 4 using the division property of inequality, don't use the division sign with the 2 dots. Use a fraction bar, please. Fraction bar, fraction bar, fraction bar, fraction bar. Then this inequality stays the same. 32 divided by 4 is 8. I've got an n all by itself. Ooh, man, this guy's got skills, let me tell you, man. He's got skills. This time I'm going to put 8 here, and let's see, I'm going to be weird, and let's see if you can figure out what I'm counting by. I'm going to go 16 here and 0 here. Yeah, I'm sure you already figured out. I'm counting by 4s. Okay, n is greater than 8. Well, so I substitute in 0. Is 0 greater than 8? No. Is 4 greater than 8? No. Is 8 greater than 8? No. Is 8.2 greater than 8? Yes. I don't know, maybe 8.2 is like there. I don't know. Wait. That means it's all the numbers up till 8. All these, I don't want to get like really close to 8 and be like, yeah, but it's not touching it. So what I'm going to do, is I'm going to use a very special open dot. Oh, look at that open dot. It's all squishy on stuff over there, but there you go. It's an open dot, which means 8 is not a solution. Sorry, 8, you're not invited. But then all these numbers over here are party. All right, guys, in my math party, you're all greater than 8. Try 16. Is 16 greater than 8? Yes. Pac-Man would be like, give me that 16. Don't give me that 8. Okay, what was n being done? What was being done to at the beginning? N was being multiplied by 4. So what are we going to use? We're going to use division to undo the multiplication. Vertical lines. Remember to check your graph by substituting. Oh, I've not left myself enough room. Can he do it? Oh, gosh. Are you guys on edge? Can he fit the ing? Can he fit the ing? Can he fit the suffix? Woo! I'm very proud of myself. A value from your graph into the inequality. That's what we did. We were substituting these into the inequality to check if they made the inequality true. Man, we are just plowing through this. I cannot believe how good I am. Oh wait, I mean we are. Oh, how do you?